Welcome to Substrate Seminar, everyone. And Dominik, so good to have you. How's it going?
Yeah, hi, I'm fine. Good. It's good to have me here.
Yeah, I'm really excited to have you on, especially to dive into the topics that we're going to cover. Um, we've already had a seminar historically about Open Brush, and it's really kind of going to be interesting to see the new developments around it and maybe things you have to share. But just like to kick things off for today, I want to welcome everyone that's kind of streaming in and tuning in on Twitch. We are as you know, Dominik, you're experiencing sort of this new way of doing seminar where we're streaming using Twitch, and eventually we're going to branch out to other platforms, hopefully like also live stream on YouTube to make it as accessible as possible. So why seminar? Because we want to put out like really useful material for developers learning in the ecosystem, building on Polkadot. And seminar is really a place to share knowledge for developers to engage with other developers. So on that note, use the chat, like say hi, engage with the people that are in the chat, and ask questions. And if you haven't already found the repository for seminar, we have this repo that we use to allow community members to suggest new seminars and also comment on ideas that they have that they'd like to see. And so this brings us to today's session with Dominik here, representing Brushfam, where they just wanted to kind of join and chat about these tools that Brushfam provides for Ink smart contract developers. So that's what we're gonna dive into today. Yeah, I guess Dominik, give us a little bit of your developer journey, what you've been working on lately, what's your involvement with the project, and what you're most excited about.
Yeah, okay. Hello, my name is Dominik. I'm the head of engineering at Brushfam. And okay, you were talking about the developer journey, so I will say that I'm in the Web3 space for 2 years, like as a developer. Before I was developing Android applications. And I was interested in Web3 because I was into Bitcoin and decentralization since 2017. Then I found out that you can create programs on like on the blockchains. So I went into Solidity, and then I wanted to start working in Web3, and somehow I got into Polkadot development, and I found out that Ethereum and EVM is not as good as, for example, the Wasm or Polkadot could be. So I'm glad that I can develop this infrastructure and work on things that will probably be the future of smart contracts. So what we are working on in Brushfam is we are maintaining the infrastructure tools for Ink smart contract development. Many of you probably know about Open Brush, which is smart contracts library for Ink smart contracts. We like to refer to it as Open Zeppelin for Polkadot, but it's not exactly Open Zeppelin for Polkadot. Of course, we have some contracts templates in this library, so you don't need to code some fungible, non-fungible tokens, access control, whatever, on your own, but you can use these contracts that are provided within the library. But also, since Ink is based on Rust and there is so many possibilities with Rust, we also provide. It is sometimes hard to write some code in Ink, and what we do in Open Brush, we provide also some useful macros for Ink smart contract development. So I will say one example. For example, to do a cross contract call in Ink, it's like 4 lines. With Open Brush, we provide macro for wrappers, for contract wrappers, where you can do such call in 1 line. So that's just one example of why
So
Open Brush.
so let me just interrupt so that we kind of take things into chunks, right? So hopefully we're the overview of like today's session. We're gonna understand the basic tools that at our disposal to be using Ink smart contracts and developing them. But and then what I'm most excited about today is that we're going to actually build an end-to-end application. So we're going to actually see how to use these tools in context. I want to just, before we dive into that, let's just talk about quickly, so if I'm if I'm a smart contract developer in the Polkadot ecosystem, what does it really mean? What I know that there's a lot of smart contract chains out there. Why would I use one over the other? I mean, without going into too much detail, but let's just make sure that the audience understands what it really means to be developing smart contracts in the ecosystem. You did touch on why you're more excited about WASM smart contracts, but that might not be very obvious for people that are coming from an EVM world. So maybe touch a little bit on that. What does it mean really to be a smart contract developer in this ecosystem?
Yeah, okay. So first thing I will say is that substrate blockchains, which also Polkadot is built on substrate, are some kind of blockchain Lego. So you can take some bricks, like for example, you want your chain to enable smart contracts. Okay, you will add module for smart contracts. You want some assets, you will enable module for assets. So talking about this, there are several palettes. These modules are called palettes for smart contracts. One of them is palette contracts, and palette contracts allows your blockchain to execute the smart contracts. And these smart contracts are written in Ink, which is a embedded domain-specific language, which then has some calls to the blockchain and to the palette contracts. So the contracts can be executed. Okay. What does it mean to be a smart contract developer on Polkadot? Currently, it means develop the smart contracts. Yeah, but currently there is this problem that the smart contracts are not on mainnet yet. We are waiting for the Ink 4 version.
Yeah.
And after that, the smart contracts will be this version will be audited and should be completely safe. Right. So after this update, the smart contracts would also be on mainnet. I can about Ink, I can say that I know, for example, about Aleph 0, which is one chain which will support these Ink smart contracts, and also Astar. But I think there are many more. But this was just some examples. Yeah. And what does it mean? First of all, when we started developing some Ink smart contracts for Polkadot ecosystem, there were no such tools like Open Brush or any other tools. It was like 1.5 years ago, or rather, I will rather say 2 years ago, plus minus, and we found some hole in the system, in the ecosystem. Like there is something missing, and then we went and created Open Brush. The same with Typechain, and which is TypeScript wrappers for your smart contracts. So it has easier integration into the UI. But since then we have went a long path, and the ecosystem right now looks much better than it looked in the beginning. We have more tools like chain extensions, which allow your smart contract direct communication with the blockchain or with some of the blockchain's modules. We have also Swanky node from Astar, which works somehow like Truffle for Ethereum, for EVM contracts. So but we still have stuff to do. We still see some holes or some problems that the developers find, and we still need to fix it. But it's a lot easier. So
Yeah, I guess just like to summarize, I think that there's basically when what we're talking about is WASM smart contract development in the Polkadot ecosystem, and it's a relatively new area, right? Like, I mean, the pilot contract's first iteration was probably about 3 years ago, when before Polkadot was launching, and there's been a lot of improvement to it, right? So the contracts palette, for those listening, is really just the WASM execution environment for the smart contract, akin to what an EVM would be, right? So it's like having a virtual machine in your chain. So yeah, I think like what's exciting about having you guys do this amazing work is that you're making it easier for smart contract developers coming into the ecosystem to just develop, right? To focus on building secure and robust decentralized applications that can run on these parachains that support smart contract execution.
Yeah.
And I think the second thing to note is that what does it mean to be a developer in the Polkadot ecosystem building smart contracts? Well, I think there's something to say that you are more you have like you have more possibilities actually to extend your smart contracts, because we have this concept of chain extensions, right? So I think their Open Brush docs are really good. I highly recommend for people to check it out. And they have examples with chain extensions. The chain extension, really all it is, it's saying, okay, I have a smart contract that can call into the runtime. I think there's actually an example on about the assets palette, right?
Yeah.
So you can call into these different palettes of the substrate built runtime. That's really powerful. I think that means that there's going to be some really exciting things that are going to come in the next year or so with really like using these features. Are there things that you are like particularly excited about to see?
Yes. Also, on top of that, Solidity, I will also talk about Solidity. Solidity is just built for smart contracts, and it has some limitations. But when you come to the Rust smart contracts, you have no limits basically, and this is what I like, that I can basically do anything that maybe is not possible in Solidity. So that's one thing. Also, WebAssembly is maintained by the Bytecode Alliance, which are the biggest tech players in the industry. So that also says something about the speed. And also, when we talk about the transactions like blockchains, it's less expensive and more. I forget the word now,
Secure,
but it's
more.
it's better. I
So
wanted to say
I think the word I would use is like modular. Like, I really admire how the Open Brush, like if you were to use Open Brush, you quickly find that there's a particular structure to structure each contract. You have an impl folder, you have a traits folder, and then you have your contract folder. And really, like,
Yes.
that just allows you to really extend. So you can have in your contracts folder just a simple kind of very generic contract that then is only being implemented in these other folders, which means like it's very helpful for like how do you say this?
Yes.
Reusability,
Yeah,
economics.
reusability, and also for better architecture, because the smart contracts in the final way are just computer programs, but computer programs need to be structured in a good way, so for some maintainability and some better understanding of the application. So yeah, this is also one thing that's like better than the Solidity contracts.
Yeah, and it's all written in Rust, and I think that kind of gives a lot of superpowers with especially interacting with Substrate, right?
Yeah.
I think that's something that even parachains running an EVM module, well, the limitations there are that there's less compatibility with the Substrate node, really.
Yeah. Also,
Yeah,
I want to say one word, which is interoperability, and that's interoperability between chains, interoperability between contracts and chains via the chain extensions. So yeah, the possibilities are endless,
Yeah.
basically, with Substrate and Rust.
Yeah, absolutely. One thing we didn't explicitly call out, but I'm sure that anyone that's a little familiar with Polkadot would be familiar with is XEM, and so we have the ability to actually make XEM calls from and to smart contracts, and a couple of parachain teams are really spearheading this work, in particular Astar, and other teams, I'm sure.
Yeah.
So, which is really cool. But today we're just talking about, okay, what would it look like if you just wanted to build something on Polkadot? We're not talking about where you're going to deploy it or anything. We're literally just talking about building a smart contract, building an application really, using Open Brush and the Polkadot's TypeScript tool, as well as the Soul to Ink, right? So like the transpiller. So there might be developers out there that are very Solidity first and they're still learning Ink, and it might be a nice idea for them to take a Solidity smart contract and transpile it into Ink, right?
Yeah, and this is one thing I have. I am noticing that a lot of new guys who are trying to build on Ink, they come from the Solidity ecosystem, and they are experienced with writing Solidity applications, but they had maybe little or no experience with Rust, and even less experience with Ink, and they are struggling with this. So yeah, a tool like Soul to Ink, for example, is very useful here. Open Brush and Typechain, those are for easier integration, easier development of these smart contracts. But if there's something, if somebody wants to learn Ink and they know Solidity, they can basically take their Solidity code, run it with Soul to Ink, and see the Ink output, how it looks in Ink.
Yeah, that's super powerful. So I mean, let's just dive into the plan for today, and then I'm assuming you have some stuff to share for us.
Yeah.
We'll be looking at well, let's take things step by step, and then super excited towards the end. We're just going to build something using these tools. So just a quick recap of our plan today. We're just going to talk about each individual tool in isolation. So what's Open Brush, the different macros that you could use, and then the typechain Polkadot. I think we should dive right into it. Maybe you can share your screen.
Yeah.
And yeah.
Okay.
And
So
also, people in the audience, really, this is an opportunity for you to ask any questions. Like ask a dumb question, ask something that you're not too sure of. Like we talked we talked about a lot of things up until now, covering the overview of the ecosystem and what does it means to be a smart contract developers. Maybe you're looking to become a smart contract developer and you have some questions for Dominik. Take the advantage to use the chat and don't be shy. So during our session today, feel free to ask a question. I'll interrupt if it's relevant, or we'll just leave for a Q&A at the end. So yeah, make sure that you're jotting down any questions and stuff as we go through this.
Yeah, okay.
The floor is yours, Dominik.
Okay. Okay, thank you. So we Sacha has mentioned some projects or products that we are developing, that we are maintaining. So I will talk about each of them. First product is Open Brush. It's, in my opinion, the biggest infrastructure tool in the Polkadot and Substrate smart contracts ecosystem, in Ink smart contracts ecosystem. And what Open Brush does is, as I mentioned before, it's a library for Ink smart contracts. So I will here open. This is the GitHub page of Open Brush, and as you can see, here we have some contract standards. So we have standards for PSP22, which is the ERC20 for the Polkadot ecosystem, and we have PSP34 standard, which is the non-fungible token, PSP37, which is the multi-token standard. I will just quickly show how the code looks, for example. So
can you zoom in a little bit just so we can see it more clear?
Yes. Give me 1 second. I will need to
Command plus or some depending.
Yeah, Command plus didn't work for me. So. Okay.
Okay, sweet.
Okay, so this is incorrect. Okay, so yeah, I think it's better now. So these are just the standard function described in the PSP22 standard, and we can see that we have some functions like total supply, balance of elements, transfer. Here is also the logic for it, and how you would import this contract into your, or import the standard into your contract, so you don't have to do it yourself. We will show that later, but it's really easy. And so this was just the PSP22. We also
So
have
quick note, like, you want to tell the audience what these PSPs are and the standard?
yeah. Okay. Yeah, for
created?
sure. So PSP means Polkadot Standard Proposal, and it's basically standardization of the contracts. And why is it needed? I think that the smart contract developers are familiar with it. It's for the interoperability, because for example, if we want to build a DEX and we want to have multiple tokens there, they all have to implement the same interface. So if I want to transfer tokens, I will always have to call the same transfer function. So that's why we have PSPs and why we need them, for the interoperability and for the interoperability and standardization. So these standards are all implemented in the Open Brush contracts. And apart from these PSPs, we also have some basic functionality like access control. So for your application to have some owners, admin accounts, and stuff like that. That's all here. I will also show you the Open Brush website, because here we have some wizard, and maybe you will need some PSP22. Okay, yeah, some basic tokens. So you will just come to openbrush.io, click try it out, and here you have the code for PSP22 for a token. Now you can just compile it and deploy it. There is also cargo toml file, which is the dependencies file for Rust, and you basically can deploy your PSP22 contract in no time. Just compile it and deploy it. But when we will be showcasing this, we will add some more logic to it. You have several extensions.
Are you able to use this browser tool to actually compile a contract?
No.
This is just
this is
kind of a
just
code editor.
yeah. This is just for showcase, and you have all these extensions here, so you can add metadata. Then it will add metadata for your smart contract, or mintable, burnable, wrapper. Okay, so anything of this. Also some access control we can add here. So now we see that there is some manager role. I will zoom it in. So this is just to showcase that even if the developers have no experience or little experience, they can play with this tool to see what it does, try to edit it themselves, and yeah, it's easy as that. Apart from this, OpenBrush also contains some macros, a lot of code generation stuff, which we don't really need to showcase. But what it does basically is just that you don't need to write that many lines of code that ink requires in order for it to work. You can just use some of the macros and it will work. I will show it later in the code. It will make more sense. And yeah, another product that we maintain is the Typechain Polkadot, which is basically TypeScript wrappers for your contracts, for UI or integration test integration. Why we need this is because you will want your application to do some calls, to perform some calls to the blockchain or to the contracts, and you can get some errors while calling these contracts. For example, you will pass integer instead of string, or you will pass some type which you think, okay, this is a good type, but then TypeScript compiles it in a completely different way. So if you are using Typechain Polkadot, you have also the wrappers, the classes for the contracts. Then you can also send the transactions to the blockchain with these wrappers. And if you have some errors, like if you are providing some incorrect types, you will be warned on the compilation. So not on the integration part. So
actually, just like a pause on that. What would you usually be using if you didn't have this tool? How would you create the
yes.
layer basically to
Okay,
interact?
so usually, and how we started, we were starting with Polkadot.js, which is what Typechain Polkadot uses under the hood, but Polkadot.js is not type safe, and a lot of stuff is painful to do in Polkadot.js. So we were using that, and since it was painful and we had a lot of errors and a lot of bug fixing for stupid bugs which were not even bugs, we were just not warned about the types. It took some time, so um, that's why Typechain was created, Typechain Polkadot. Yeah, and the integration is easy. You will just install it to your project and run it with some comments. I will showcase that too. How easy it is, and yeah. What I can.
Yeah, I'm just adding that I think it's a super useful tool, especially in that the last steps once you've kind of created a contract and then you want to interact with it. So like, what's the next step? Hopefully today we're gonna look into that, right? Like using this tool
Yeah. We will showcase this too.
Great.
So for example, the integration tests in Open Brush are uh, also done with Typechain Polkadot. So if you don't know how to integrate it, or you can also check the Open Brush and see that it's easy as that. You will create contract factory for your contract. You will instantiate your contract, and then you can just use it as if it was a contract. So these constructors, they can be also used to deploy the contract to your chain, either to your local node or to some test net, or mainnet. Not yet, because we don't have ink there, but yeah, you can do anything with it. So this is, for example, example of it. Query is the query of the contract, like performing calls. So I will show it
Very cool,
later. Okay, and another product I want to mention is Sol to Ink, which is transpiler from Solidity to Ink. Current version is 1.00, but I will be showing you newer version which we want to release in soon. And it is basically easy as that. You will just I will show you how easy it is. So Here I have some contract. I have access control in Solidity, some array contract in Solidity, comment contract. Okay, these are all contracts, Solidity contracts. I will copy path to this folder. I will cargo run, and all of those files were now transpiled to ink. We have it all in this generated folder. We have our beautiful structure, contracts, and source. So we have some impl folder where the contracts are implemented. So this is okay. Some of the stuff it cannot be transpiled correctly. I mean, it can, but it's a little more work. So we will be working on that. But you have basically the basis for your ventures, like how to come from Solidity to ink. So this is just I will try to. Oh, okay. Command plus forks. Okay, so this is like the implementation file. Then we have also some traits. So this is the public API for our contract. It would look something like this in Solidity, in Ink, I mean, sorry. And then we have also some okay, the comments are on some places a little bit broken, but comments is not what we care for. We care about how to define an event in ink. So yeah, you come to the contract and you see, okay, so this is the event. Nice. Okay, so this is maybe some storage. Makes sense. And
I'm curious, actually, Dominik, if you don't mind me interrupting. Like, so I imagine it's pretty challenging project, the Salta Ink Transpire, because you can never really have a direct mapping from a Solidity smart contract targets the EVM with Ink smart contracts. However, you can get close. So what are the challenges you faced, and also maintainability of this project is probably going to become exponentially more of a burden potentially. I guess I'm just trying to poke holes into potentially like Salta Ink and how it's going to be widely adopted in the ecosystem.
so basically, when you have the knowledge of Solidity and knowledge of ink, and you get you get some piece of code in Solidity and you are able to convert it to ink on your own, then it's no problem to convert it with the program. So for example, we know that Solidity has constructor called constructor. We know that ink has many constructors, and if we want to set some default values for contract fields, we have to do it in the constructor. So it's just you just have to play with it, but I don't think that it will become exponentially more difficult, because what you will need to do is just okay, so you will see if you are transpiling some code or somebody submit some issue. Okay, this was converted in a wrong way, this should be converted in this way. We can just simply check and see, okay, so this shouldn't be okay one, but okay empty braces. So something like that. The purpose of it is to ease the development and for the developers to spend less time on converting Solidity application to ink, because as you could see, just if I had to write this trait, okay, if I wanted to convert all of those Solidity contracts, and if I just had to write this trait, so I have interface, some public API for my contract, it would take some time, because I need to, okay, I will show it. I access control, yeah. We have this event need to be changed. Also, the position of this needs to be role colon vector of bytes, or I mean array of U8. So we have some bytes 32. So instead of spending, I don't know, maybe 10 minutes if I'm really sick of rewriting it to ink. I will and for each of those contracts I will spend 1 second and then see, okay, this maybe doesn't, okay, this looks good, yeah, but maybe there's something which doesn't look good. I will just correct it. So that's the idea behind Salt Doing, to save some time.
Yeah, super useful. And also just, I think when you're learning ink, it's probably a really neat tool to use, especially if you come from a Solidity background.
Yeah.
But, just to reiterate, you still kind of need to go and check what the transpiler's
Yes.
is, just to make sure that it's how it's expected.
Yes. But again, that's just that's just code review of another programmer, and you will just you don't have to write the code yourself. And so yeah, that's the idea behind it. Like, the idea of the future of softwaring is to produce compilable, like 100% compilable contracts, or maybe 90% compilable contracts, with less need for the checks. But the current goal of it is to help reduce time, not to write like the best application in the world. Maybe if it used some AI, it would be possible. But yeah, so that's the idea behind Saltwing.
Super cool. Yeah. If anyone has used Solta Ink in the chat, I'd be curious to hearing their experience. And I mean, it sounds like a really great tool for onboarding new developers into the Ink smart contract ecosystem. Yeah, kudos. So what do you want to do, Dominik? Do you want to dive right into sort of building, or do you still kind of want to talk about the different tools and challenges you've had and why you're excited about them? Or yeah, how do you want to move forward?
I think I have said enough. I will just and we can get right into the live coding. So I will
Sweet.
do that.